Today we're going to be learning to balance a chemical equation. I'm not sure exactly why the author of your textbook uses tables to balance chemical equations. The only thing I can come up with is that I suspect that when he's trying to put it all into words so you can read it and understand what he's trying to tell you, that a table may be the best way to organize that. However, that is not the way you actually want to do it in practice. To draw the table would be so much more time consuming than it is just to balance it by what we call inspection, which is very similar to how we determined whether a chemical equation was balanced in the last video that we looked at. And so when you balance equations, you want to do them by inspection and not by using a table, because it's much more efficient and it won't take you nearly as long. So in this video, I'm going to work the same 4 examples that he works in the book, but we're going to balance them by inspection instead of by using a table. So the very first equation that we have is a pretty simple one to balance. We've got hydrogen and chlorine that combine to make hydrogen monochloride. Now, you may look at this and go, well, why is there an H2 and a Cl2? Why don't I just put an H and a Cl? Why does the 2 have to be down there? Well, if you recall, you memorized 7 diatomic elements, and those elements always hook up together as pairs. And so whenever you have hydrogen by itself, there's always going to be 2 of them hooked together, and chlorine is going to be the same way. Now, a diatomic element does not mean that it's always a 2. It's only diatomic if it is by itself. So when I put a hydrogen and a chlorine together in hydrogen monochloride, I don't have to put 2's down there, because when they make the compound, they're going to share electrons in a covalent bond so that they are obeying the octet rule, and so they don't need to be 2 of each if they're in a compound. So I don't want you to get confused by doing that. But if you're told in a reaction that you have to use one of the 7 diatomic elements, make sure that you have a 2 at the bottom. Now, if I look at this, I have 2 hydrogens and 2 chlorines on the left, but on the right-hand side, I just have 1 hydrogen and 1 chlorine, so obviously this equation is not balanced. Now, the cardinal rule for balancing equations is that once you have each of your individual compounds represented, you must not change the subscripts. The only thing you can do is to put numbers in front of these in order to make them balance. So it's almost like once you get this written and you know that it's right, you can almost like put a box around it and say anything within that box you're now not allowed to change. So in order to make this balance, since I have 2 of everything on this side and only 1 of everything on this side, if I put a 2 in front of my HCl, I then have 2 hydrogens, which is what I have here, and 2 chlorines, which is what I have over here. Okay, so that one was pretty easy to balance. They're not all quite that easy to balance, and so now if you look at the second one that's on your sample problems for video number 5, the sheet that I told you to have with you, this one's actually written out in words. And so the first job is to make sure that you get the formulas for the compounds written correctly before you can even start to balance the equation. So this one says sodium bromide reacts with chlorine to make sodium chloride and bromine. So we're going to take this a piece at a time. If I start with sodium bromide, sodium is Na and bromide is Br. Now, is that automatically the formula? Well, you need to check it and be sure that it's right. This is an ionic compound. It has a metal plus a nonmetal together, so we have to make sure our charges are balanced. Sodium's in the first column on the periodic table, so it has a positive 1 charge. Bromine is in the second to the last column on the periodic table. It has a negative 1 charge, so in this case, I only need 1 of each, and so the formula is NaBr. It says that it reacts with chlorine, so that's going to be plus Cl. Chlorine is one of those diatomic elements, so whenever I have it, I always have to have 2 of them hooked together. So that one's going to be Cl2. The next words in there says to make, and so you know that's where the arrow is going to go, to make sodium chloride. So here's sodium, and here's chloride, but again, I have to make sure my charge is balanced. We already said that sodium was a positive 1. Chlorine is in the second to the last column on the periodic table, so it is a negative 1. And so since this is positive 1 and this is negative 1, I just need 1 of each to make them balance. And then the other product it makes is bromine. And so bromine is a diatomic element, and so there have to be 2 of those as well. So now when I look at this, my sodium looks like it's okay, but my bromine is not, because I have 1 bromine here and I have 2 bromines on this side. Now remember, I can't change the subscripts. I can't go in and just stick a 2 down here, because if I do that, then the charges in this compound no longer balance. The only thing I'm allowed to do at this point is put numbers in the front. So if I have 2 bromines over here, I'm going to have 2 on this side, so I'm going to put a 2 in front. Now I have 2 sodiums, so now I need to go over here and put a 2 in front of those sodiums. I have 2 chlorines here, and I have 2 chlorines here, so now I have everything balanced. You should always go back and make sure, once you think you have it balanced, go back and check it again, just to be absolutely positive. So 2 sodiums, I have 2 bromines here, 2 here, 2 chlorines here, and 2 on this side. So this equation is now balanced. Okay, let's look at the next one as an example. It says phosphorus pentachloride and water react to make phosphorus or to make phosphoric acid, and I give you the formula for that one, H3PO4, and hydrogen monochloride. Now it's nice when we've got 2 nonmetals put together, because then you just have to look at the prefixes to know exactly how many of each one you need. So phosphorus pentachloride, so phosphorus, penta means 5, so the correct formula there is Cl5, phosphorus pentachloride, and water, so water is H2O, react to make phosphoric acid, and the formula for that is H3PO4, and hydrogen monochloride, so that's HCl. Okay, now one thing that you will notice in this particular reaction is that the phosphorus and the chlorine are both just in one place on each side, but the hydrogen is in 2 places on this side. So because it's in 2 different spots, I'm going to save that one till last, and hopefully by the time I get everything else balanced, the hydrogen will be balanced as well. So I have 1 phosphorus here and 1 phosphorus here. So my phosphorus is balanced, and that looks okay. The chlorines, I have 5 on this side. So if I have 5 here, I've got to put 5 over here. Remember, the only place I can put it is up front. You can't add any subscripts. They only can go in front. So I've got 5 chlorines and 5 chlorines there. Okay, let's look at the waters now. Or let's look at the oxygen. Remember, we said we were going to save that hydrogen till last. I have 1 oxygen here, and I have 4 over here. So if I'm going to get my oxygen to balance, I'm going to have to put a 4 in front of the water. Now I can check my hydrogen, because the phosphorus, the chlorine, and the oxygen are balanced. So now let's see where my hydrogen has left me. I've got 4 times 2 is 8 on this side. I have 3 here, and I have 5 here, which makes 8. Okay, so that means that everything in this equation is now balanced. Again, go back and check it, make sure you haven't missed anything, and that you've got everything all correct before you decide that you're finished. Okay, so that's a key hint that you can look at. If you've got one element that appears in more than one compound, save that one for last, because a lot of times that will be balanced by the time you get everything else balanced. All right, the last one we're going to look at is a combustion reaction, and I've got C4H10 plus oxygen is going to yield carbon dioxide and water. Okay, now again, my carbon and hydrogen are each just in one place. My oxygen is in 2 places over here, so I'm actually going to save that oxygen for last and hope that it works out nice like it did up in the one before. Okay, so I've got 4 carbons over here, so that means that I need 4 carbons over here on this side. I have 10 hydrogens over here. I have 2 here. Well, what can I multiply this by to take 2 up to 10? Well, if I multiply this by 5, 5 times 2 is 10, and then I've got 10 over here. Okay, so my carbons and my hydrogens are balanced now. Now let's check out the oxygen. I have 2 on this side. On this side, I have 4 times 2 is 8, and I have 5 here, which makes 13. I have 13 on the right, and I have an even number on the left. And that really doesn't work very well because there's no nice number that I can multiply this by to make that an odd number. So we're going to use an algebra trick in order to make this work. I really need 13, right? Because that's how many were on this side. So if I put a 13 up here, what I really need, because there's 2 of them, I need to multiply it by 13 halves, because 13 halves times 2 will give me 13. But the problem is you can't have 6.5 oxygen molecules. We already talked about how you can't have just 1 oxygen atom by itself. So this really doesn't work. It makes my numbers work, but it doesn't work in real life. So now what I'm going to do is, this is just like an equation in algebra. You can multiply everything through by the same thing, and then everything stays the same. So if I multiply this by 2, this just becomes a 13, and it makes everything look nice. So therefore, I'm going to multiply everything through by 2. So I'm going to put a 2 in front of here. I'm going to take 13 halves times 2, and I'm going to make it a 13. I'm going to multiply this by 2, and I'm going to make it an 8. And I'm going to multiply the 5 by 2, and I'm going to make it a 10. So now let's go through and make sure that everything is still balanced. So I have 2 times 4 is 8 carbons, and I have 8 carbons here. I have 2 times 10 is 20 hydrogen, and I have 10 times 2, which is 20 hydrogen on this side. Over here, 2 times 13 is 26 oxygen. On this side, I have 2 times 8, which is 16, plus 10 more. 16 plus 10 makes 26, and that's how many I had on this side. So everything is balanced now. So what you can get from this is that sometimes, especially in a combustion reaction where you're trying to balance this oxygen, this is the most often time when you're going to see this, you're just going to have to go through and double everything to make that oxygen be able to come out right. It doesn't happen in every combustion reaction, but it does happen in quite a few of them. So if you see a reaction that looks like this, where you're trying to balance that oxygen, sometimes just going through, once you've got everything else balanced, multiply everything by 2, and then be able to get that one balanced as well. Balancing equations just takes some practice, and so not only are you going to be working some problems in the book, but I've also given you an additional worksheet for practice this week. And so once you work that worksheet out, and I've sent you the answers, and then you'll also have the ones in the book, hopefully you'll be really good at balancing chemical equations.